Hi, good evening. I am Tejashwini Parashuram Hanchate, CZ combination 5th sem. My topic is metal carbonyls. In this class, we study about the metal carbonyls. Some points are we study in this session. Those are a definition of the metal carbonyls, why we study the metal carbonyls, pi bonding, sigma bonding, classification of a metal carbonyls, physical properties, synthesis of the metal carbonyls. Let's we know about the definition of the metal carbonyls. See the structure. Here the name indicates the compounds contain a metal and carbonyls group, are we called a metal carbonyls. M means central metal atom or transition metals. D block elements. The transition metals are D block elements. These are a vacant orbitals. They stable the complex. For example, FeCO5 and NiCO4. CO means carbonate oxygen. The clear definition is that these are a coordination complexes of the transition metals with the CO ligands. Then one question is arise here, why we study the metal carbonyls? Because these are considered as a very strong Lewis base and forms the strong bonds to the metals in a complexes. These are usually zero oxidation state, and sometimes they have a negative oxidation state. CO is one of the strongest pi electron acceptor ligands. Another point is here, these are used as a catalyst in the chemical industry. That's why we study about the metal carbonyls. Then we move to the next slide. Here observe this. Pi bonding and sigma bonding. Sigma bonding means here CO ligand donates the electron to the central metal atom, and pi bonding means the central metal atom is donate the electron to the ligands, means CO. The sigma bond, why we call the sigma bond, means the ligand donate the sigma electron to the central metal atom, and here the central metal atom donates the pi electron to the ligands. That's why we call the sigma bonding and pi bonding. Pi bonding also called as a back bonding. Then we go to the classification of the metal carbonyls. There are two types of a classification: homoleptic carbonyl compounds and heteroleptic carbonyl complexes. Homoleptic carbonyl complexes means in this complex in which the central metal atom is only bound to the ligands, that's why we call the homoleptic. The central metal atom only contain the same type of the ligands. For example, NiCO4. Here central metal atom Ni contain a single, means same CO4 atoms surrounding Ni. And another example, Cr, CO6 and FeCO5. And next, heteroleptic carbonyl compounds or complex. In this type, the metal atom is bound to the CO as well as other ligand. For example, NiCO3 PF3. Here central metal atom is attached to the CO as well as the another ligand PF3. That's why we call the heteroleptic carbonyl complex. Then there are two types of heteroleptic carbonyl complex: bridged metal carbonyls and non-bridged metal carbonyls. Non-bridged metal carbonyls means these are carbonyls contains a terminal CO ligands and MM bonds CO2. Bridged metal carbonyls means these complex contain a bridged and terminal CO ligands. Bridge means the bond between a two central metal atom. What we call here bridge means bridge. The bond between a two central metal atom is called a bridge. For example, Fe2CO9. The Fe2 Fe between a bond is formed. The bond is called as a bridge. Now we'll study the physical property of the metal carbonyls. Here the state properties are differentiated into the state, color and solubility. State means most of the metal carbonyls are liquid and volatile solids means evaporation. Color is depends upon the number of the central metal atom. If it is a monomolecular carbonyls, they are colorless to the pale yellow. If they are a polynuclear carbonyls, they are in a dark color. Means the central metal atom is more, they are in a dark color. If they are in a less, they are in a colorless to the pale yellow. Means in a pale color is happened. Then we go to the solubility. They are soluble in organic solvents, for example benzene, ether, etc. And now we study about the synthesis of the metal carbonyls. First step is direct reaction of the transition metals with the CO. Here nickel reacts with the carbonyl monoxide and forms the NiCO4. It is extremely toxic liquid. Then another example is Fe reacts with the, here it is below the slide, Fe reacts with the 5CO and forms a FeCO5. Observe here some complexes are synthesized. Here my topic is end. Thanks for all. Thank you so much.